Pause the video, give this question a go first, and then I'm going to give you a solution. Okay, ladies and gentlemen, so what we have here is your solution. Front is also known as the head, tail. Describe how octopus is added to the given queue. Well, what will have to happen is you can mention, even though it's not on here, the 3-pointer is pointing to position 4, where octopus will be added. This will increment or add 1. The end of Q pointer, I'm just going to do EOQ, i.e. the tail, by 1. So it is at octopus, position 4. Okay, I'm running room. Right. And 3-pointer is now 5. So it's incremented. There you go. Nice and easy. Okay, so this next question, I and I, I'd like you to give a go yourself first, and then I'm going to give you a solution. So pause the video, give it a go. Okay, so describe how the next item in the given queue is removed and stored in the variable animal name. So if we were to DQ, which is to remove, it will be frog, which goes. So I'm going to mention that, so in the code, you could do something like this. Animal name, DQ, and we're going to DQ and hold on. So what that'll do is it'll take frog and put it into animal name. So if I want to do print animal name and just do AM animal name, it'll display frog. So the question is, describe how the next item in the given queue is removed and then stored into animal name. So let me just undo this and let's go through that. Well, what will happen is value frog, which is in front of queue, position 0, is assigned into animal name. Then what we're going to do is we're going to increment front of Q pointer by 1 to cat pos 1. So we're moving, we get rid of this and we do this. And we can mention here by DQ. So we can use DQ to do this. Describe the state of the queue when the front of the queue and the end of the queue pointers have the same value. This basically means, so let's imagine that we've got rid of this and we got rid of this. So we've got front and end at the same. It means we've only got, so we only have one data item in the queue because the tail and the head are in the same position. The moment we add something else, the end of the queue is going to be here. So they're no longer in the same position. So the only time they're in the same position is if you've only got one data item in the queue. Pause the video, give this a go first. Okay, so some operations are carried out on this original queue. This is a current state. Complete the diagram to show the state of a queue after we do the following. So if we ask wasp b mouse and then remove two different data items, so DQ, so the rules of the queue, it's going to be first in, first out. So frog will go and cat will go. Okay, I've got it. So now I'm going to add it into here, wasp. So that's just me planning it first. B mouse. I then need to add the pointers. End of queue, front of queue. And there we go. Nice and easy. Do not forget the pointers. Even though it mentions nothing about pointers in the question, that is what it's looking for. These actually carry 1 mark, and all of this, 1 mark. Okay, so we now got, in fact, pause the video, give this a go yourself first, and then I'm going to talk about the question. Okay, so what we've got here is our actual queue. It starts on 3, finishes on 6. Ant, you can say, has been DQ'd but not cleared. Fish, cat, frog. So these are basically, we can imagine they're just not here. But just haven't been cleared out. Because if you DQ, you need the code, you can set the code so it keeps it in there still, just in case you want it later, or to erase. So I'm just going to erase these. Very nice, there we go. So what we're going to do is now, it says we're going to remove an item. So if we're going to remove something, what's the first thing to remove? Well, the front of the queue is going to be Elk, so that's going to be the next person. Imagine it's a doctor's surgery to see the doctor. They're next in line, for next in the queue. And then what we're going to do is we're going to add dolphin and then add shark. Well, the next available free space, the 3 pointer, is pointing to here because it's the first space after the end of queue. So that's where we're going to be adding dolphin. Dolphin. And then we need to be adding another item, which is going to be shark, which will go here. So if we were to do this, it'll be shark, and I'm going to put in brackets like this, cat. It's not part of our queue anymore. It's like being disconnected. Wasp, bee, mouse, dolphin. So as we got rid of elk, the next front of queue is wasp. So I'm going to do that here. Front of queue, and we add a dolphin. So the 3 pointer moves, the 3 pointer was there. Then we added shark, so the 3 pointer is here, which means that the end of the queue is here. So end of queue is going to be on shark. And there we go. Done. Okay, so please can you pause the video and give us a go? And then I'm going to go over this with you. All right, describe. So we're kind of like using structured English to modify the end of queue pointer. All right, so we've got our queue. So we're going to call this, what do we call it? Top, first? Let's just call it head. Stop that. Tail. And we've got, I don't know, 3, 2, it was FAQ, isn't it? That was it. Alright, so describe the algorithm that you would use to modify the end of queue pointer when adding an item to the queue. Well, step 1. We need to see if the queue is actually full in the first place. So before we actually add anything to the queue, we want to see if all the spaces are taken up. So, if front of Well, actually, we can't use if front of queue is going to be the same as end of queue, because that could be that is not full. So let's use, I'm going to mention use 3-pointer. If 3-pointer is -1, then display queue is full, which makes sense. We need to take that into account. Number 2, if it's not full, so let's have this end of queue here, increment end of queue by 1 to the position of 3-pointer. Increment 3-pointer, but if at end of queue, so let's imagine we've got a situation like this. So if the end of queue is here, we can't increment the 3-pointer. If end of queue state -1, because we're full. And finally, when we dequeue, so let's say this goes, three-pointer becomes whatever the old head of queue is. Sorry, first of queue. So what I mean by that is this: if we have a number in here, let's say 9, and we decide to dequeue, and we remove whatever's in here, the 3-pointer, so remember, this would have been our first of queue. So what we're going to do is, if we're going to dequeue, when dequeue, we set 3-pointer to be old FOP. If 3-pointer is -1. So we're going to get rid of this. First of queue here, and now 3-pointer becomes here. So to manage what we call a circular wrap. So think of it like this: if we had a queue which was like this, let's say 4, 2, 3-pointer will be here. If we fill this up, let's imagine we're going to put in 8, 3-pointer goes up by 1, that's fine. Let's imagine we put 9 in, 3-pointer becomes -1. And let's imagine that we dequeue then, 3-pointer is now going to be here, which is where the old head was going to be, or should we say FOQ. So this will now be front of queue. So that's what we just talked about here. We talked about if 3-pointer is -1, that means that everything is inside the list, inside the queue, sorry. The moment we remove something, again, the 3-pointer, if it's -1, will wrap around to go into there. That handles the wrap.